Hello, ladies and gentlemen. So we are going to review what you need to know for your next learning check. So these are all the standards that you need to know for your next learning check. And if you don't want to keep watching the video of me going through this sheet of paper, I do have this sheet of paper posted as a PDF too. Okay, so there's 6 standards that are going to be on your next learning check, and the first one is going to be RTT1, which is the Pythagorean theorem. We should know by now that the Pythagorean theorem is a squared plus b squared is equal to c squared. And we'll go over the last learning check that you guys took together, because a squared plus b squared equals c squared should be pretty simple, but there's a couple times where people forget that the c squared is the hypotenuse, or in a picture, the hypotenuse is across from the 90 degrees. Some people make mistakes like that. And then also there was a factoring problem on the last learning check that we can talk about what happened there. Okay, RTT2, the converse of Pythagorean theorem. So what would happen if this is not equal to the c squared? If we took the small side squared plus the medium side squared, what happens if it's not equal to the largest side squared? Well, if the c squared is too small, then it's acute, and if the c squared is too big, then it's obtuse. Okay? And then the last ones, oops, sorry, I'm trying to adjust my camera. The last ones are RTT3 and RTT4. RTT3 is the special right triangles. There's 2 types of special right triangles. They're 45, 45, 90 degree triangles, and then 30, 30, 60, 90 degree triangles. So we found out from the video a long time ago about special right triangles that for every 45, 45, 90, because it's an isosceles triangle, the 2 legs are always going to be congruent to each other, and every single time you try to find that hypotenuse side using Pythagorean theorem, it's going to be the leg times the square root of 2. So that's where this shortcut comes from. The leg times the square root of 2 is equal to the hypotenuse. And then for the 30, 60, 90 ones, so that originates from if you have a equilateral triangle with 3 60-degree angles, right? And then if you were to cut it in half, that makes this a 30 degree and 30 degree and 90 and 90. So let's say, I don't know, our side length of our equilateral triangle is 3. Oh no, that's an ugly one. Let's try another one. Let's say it's 4. Then on this side, that would be half of that, which is 2. And then if we found with Pythagorean theorem, we would find that this long side is 2 square roots of 3. And that's where we get that for the shortcuts. So if we see from this picture, the hypotenuse is equal to 2 times the short, or it's half of that short leg, and then that times the square root of 3 gets us to the long leg. So that's where this comes from, okay? So if you have a hard time remembering these shortcuts on how to use them, this is how I remembered it when I was your age, or when I took geometry. I would write my T-chart out. I would know that 45s were on the left, and then 30, 60, 90s were on the right, and this is what I would do. So watch very carefully. I would go hip, hip, long, short, short, leg, 2, 2, 3, square root, square root. I'll say that again. If you have trouble memorizing this T-chart and you want to use it for your next learning check, this is how Littlefield memorized it. Hip, hip, long, short, short, leg, 2, 2, 3, square root, square root. Every time I wrote it down, I didn't write it down left to right and top to bottom. I wrote hip, hip, long, short, short, leg, 2, 2, 3, square root, square root. Okay? So hopefully that helps. And then we have the SOHCAHTOA, or RTT4. Remember, SOHCAHTOA solves for sides, and then the inverse functions solve for angles. So SO represents the trig function sine, which is the opposite over the hypotenuse. Cosine represents the adjacent over the hypotenuse, and the tan function is the opposite over the adjacent. The inverse would solve for angles. So that's like sine inverse of opposite divided by hypotenuse, cosine inverse of adjacent divided by hypotenuse, and then tan inverse of opposite over adjacent. That would solve for an angle that you were trying to find in a triangle. Okay. So for reciprocal trig, we know that sine, cosine, and tangent have what we call 3 reciprocal functions. And remember, reciprocal just means like the flip of a fraction. So the reciprocal function for sine is cosecant, or CSC. The reciprocal function for cosine is secant, oh my gosh, SEC, okay? And then tangent's reciprocal is cotangent, or COT. So if we had a picture where they gave us all 3 sides and then gave us a reference angle, all we would have to do after that is solve for the proportions, or sine would be the opposite over the hypotenuse, and then cosecant, so the flip of that, or the reciprocal of that ratio. Cosine is the adjacent over the hypotenuse, and then secant's the reciprocal of that. Tangent is the opposite over the adjacent, and then cotangent's the reciprocal of that. Okay, so for the learning check tomorrow, it'll give you a picture like this. You'll have to find the missing side, and then these trig functions will be listed for you, but the ratio spots will be blank. So you'll just remember that sine goes with cosecant because it's across from it, cosine goes with secant because it's across from it, and tan goes with cotant. Just for this learning check though. After that, you'll have to start memorizing the 6 trig functions, okay? And then what we just learned yesterday was, here I'll move my little guy, was converting radians and degrees. So if you watch that M&M lab video that I showed you, we found out that every circle has 360 degrees, and then there's another way you can measure angles, not just with degrees, but called radians, which is based off of the radius of a circle. And every circle has 2 pi radians, or 6 in that little sliver, so 2 pi. So when we convert from radians to degrees, or degrees to radians, we have to use this ratio right here, where it's going to be the number of radians over 2 pi over, or equal to the number of degrees over 360. So if I want to solve this guy, here I'll move my thing. Okay. I'm going to use this ratio. So the first example is convert from radians to degrees. So my radians is 7 pi over 6. So that means I'm going to put 7 pi over 6 all over 2 pi is equal to x over 360. So we cross multiply, so that's going to be 2 pi x is equal to 7 pi times 360 all over 6. So we have to take 7 times 360, which Littlefield doesn't know off the top of her head, so I'm going to get my calculator out. Okay, 7 times 360. Oops, my calculator's being funky. 7 times 360. That is 2,520, and hopefully it's divisible by 6, so we can reduce this down. Yes, that's 420. So we have 2 pi x is equal to 420 pi. Divide by 2 pi, divide by 2 pi. The pi should always cancel, because if we're going to get a degrees as our final answer, the pi should cancel. And then 420 divided by 2 would be 210 degrees, is the same as 7 pi over 6. Okay? If we're going to be doing now, converting from degrees to radians, now we're going to have 315 over 360 is equal to x over 2 pi. So 315 times 2 is 630, keep pi as pi, is equal to 360, x, divide by 360, divide by 360. And then we have to simplify 630 divided by 360 as a fraction, and that's 1.75, which as a fraction is 7/4. So that is what our radians are for 315 degrees. Radians. Okay, hopefully this review helped you. For the learning check next time, not all of these will be final attempts. But the final attempt should be Pythagorean theorem, converse of Pythagorean theorem, and then of course special right triangles. So these are all the things that you need to know. You have to remember Pythagorean theorem, the converse, the special right triangle shortcuts, SOHCAHTOA and inverse SOHCAHTOA, and then reciprocal trig and converting radians and degrees. And again, I posted this on the Google Classroom page. Okay, so let's talk about the last learning check and how it went. Okay, so this is the last couple questions for these are the questions from the last learning check. Sorry, I'm trying to get my camera to focus, but it's not really working. Okay, there we go. Okay, so for part A, we had the 90-degree angle was right here. So that means that my c squared side was x plus 1. So I had to take x squared plus x minus 7 squared all equal to x plus 1 squared. Let me see. Maybe the shadows are messing with this. I'm so sorry, you guys, that you can't see this. This is going to be a little frustrating. Okay, there we go. Okay, so we had to take x squared plus x minus 7 squared equal to x plus 1 squared. So what happens though when you take x plus 1 and you square it, you actually have to remember that exponents are telling you to multiply this whole expression twice. So it's going to be x plus 1 times x plus 1. So if you have to do this multiplication, that means that you're going to have to FOIL, which is x times x, x times 1, 1 times x, 1 times 1, which gets you x squared plus 2x plus 1. So almost all of you guys, if not all of you guys, did x squared plus 1 for that side, which is how you messed up because you forgot the o and the I in the FOIL. And then you had to do the same thing for x minus 7. So what should have happened is you should have gotten x squared plus x squared minus 14x plus 49 is equal to x squared plus 2x plus 1, and that converted to, or combined like terms, to 2x squared, and then you had to subtract everything over to get 0 on one side, and then you had to factor again. So it was x squared, once you got everything to one side, it was x squared minus 16x plus 48, and then you had to factor from that. So two numbers that multiply to a positive 48, but add to a negative 16. So that would have been negative 4 and negative 12. And so then you would set both of those equal to 0, and then you would get your two solutions as 4 and 12. But if you look back at the picture, if we plug in 4 on this side, that gets us a negative side length, which means x is equal to 4 is an extraneous solution, so your only solution was x is equal to 12. So even though this was just Pythagorean theorem, you have to remember when you square something like that, really what you're doing is taking x minus 7 times x minus 7. It's a gross 7. Okay, next question. Remember that the C side is across from the 90-degree angle. So the C side would have been 26. So you should have done x squared plus 24x, or 24 squared is equal to 26 squared. So 24 squared was 576, 26 squared was 676, subtract, you get 100, the square root of 100 is 10. Okay? Okay, moving on to the reverse of Pythagorean theorem. Okay, so these were our three sides, 11, 12, and 22. So the first thing that I did, if you notice, is that I checked if the two smaller sides add up to be greater than the third side, because if they don't, then that means it doesn't even make a triangle. So 11 plus 12 was 23, which is greater than 22, so I definitely know that this makes a triangle. Okay, and it said, which of the following statements must be true? The triangle is acute, the triangle is right, the triangle is obtuse, or the triangle does not make a triangle, the sides do not make a triangle. That one we know is true, so we can eliminate, or that one was false, excuse me, so we can eliminate option D. So the next thing I had to do was use Pythagorean theorem. 11 squared plus 12 squared equals 22 squared. So 11 squared plus 12 squared was 265, 22 squared was 484, and that C squared was too big So that means that if my hypotenuse side is too big compared to that number, then it's an obtuse triangle. Okay, moving on to the second multiple choice. Suppose the triangle has side lengths of 9, 12, and 15. Which of the following statements must be false about the triangle? So the first thing I checked was, is 9 plus 12 greater than 15? Sure is. So it says that the sides can make a triangle. Well, that's true. It's asking us for things that are false. They said the side length of 15 yards is the hypotenuse. That's the largest side, so that would be true. And then it says the triangle is a right triangle. So if I were to check 9 squared plus 12 squared is equal to 15 squared, I got 225 equals 225. If those two numbers equal each other, then it is indeed a right triangle, which means that it should be option C. The false answer, or the incorrect option, would have been the triangle is obtuse. It's not obtuse because it's a right triangle. Okay. Number 4, suppose a triangle has side lengths 13, 8 squared to 3, and 16. Okay, so 13 plus 8 squared root of 3 is definitely going to be greater than 16, and I know that 8 times the square root of 3, if I plug that into my calculator, oops, I hit the wrong button, 8 times the square root of 3 is 13.85, which means that 16 is indeed the C side, or the longest side. And so it says, which of the following statements must be true about the triangle? So I went down here and I did 13 squared plus 8 squared to 3 squared is equal to, and I don't know why my stuff erased, is equal to 16 squared. Okay, so 13 squared was 169. When you square 8 square roots of 3, when you square that, remember what's happening is you're taking, well, I'll do it up here so you can see, 8 square root of 3 times 8 square root of 3. If you're going to square something, that exponent is telling you you're multiplying this twice. So multiply the things on the outside of the radical. 8 times 8 is 64. Multiply the things underneath the radical. 3 times 3 is 9. We know that the square root of 9 can break down to 3. So 64 times 3 was 192. So 169 plus 192 was 361. Which is greater than 256, which was too small. So that C squared was too small, which meant my triangle was acute. Okay. Special right triangles. The first thing that you got to remember is the shortcuts. So I'll do the shortcuts for you. Hip, hip, long, short, short, leg, 2, 2, 3, square root, square root. Hip, hip, long, short, short, leg, 2, 2, 3, square root, square root. Okay, so that means that moving on to this guy, we had a 45, 45, 90, where 7 was the hypotenuse. So I'm using this equation. So I plug in 7, where the hypotenuse is, and then x and y, because they're legs, they should be congruent. So I just decide to solve for x, and then I know my final answer is going to be the same for y. So then, I plugged x in for the leg times the square root of 2. Well, in order to solve 7 is equal to x times the square root of 2, in order to get x alone, I had to divide by the square root of 2, which is just 7 divided by the square root of 2. And then if you go back to the video that we did for special right triangles, it's not proper to leave a radical in the bottom denominator of a fraction. So that means that you have to rationalize. And when you rationalize, like the square root of 2 in a denominator, you have to multiply by that square root in the top and the bottom. So that means that'd be 7 times the square root of 2 all over the square root of 2 times the square root of 2, which is the square root of 4, which we know is 2. So your final answer was 7 square roots of 2 over 2. Okay. I know I'm going a little fast, but if you need to rewatch the portions of the video, you can, and then you can rewind and fast forward. Okay. So this one was a 30, 60, 90. And so we know we had to use the hypotenuse is equal to 2 times the short, and the long is equal to the short times the square root of 3. In the picture, y is my hypotenuse, 12 is my long leg, and x is my short leg. So I have to use the long leg equation first. So 12 is equal to x times the square root of 3. That's just plugging in what we know about the long and short leg. The long was 12, so I plugged that in. The short was x, so I plugged that in. Divide by the square root of 3, so it's going to be 12 square roots of 3 over 3 when I rationalize. The 12 and the 3 can simplify to 4 square roots of 3. So that's x. Then my next equation is 2 times that answer, times the short. I know the short is 4 square roots of 3, which means that I have to take 2 times that. Well, 2 times 4 times the square root of 3 is just 8 square roots of 3. So the biggest thing is remembering this. Hip, hip, long, short, short leg, 2, 2, 3, square root, square root. Hip, hip, long, short, short leg, 2, 2, 3, square root, square root. Okay? Okay, and then you guys had a Eiffel Tower problem, and my legacy students didn't have a word problem yet. They'll have it on their next learning check that they took after you guys. Okay, so this was your 2 problems though, A and B. So you have to pick an angle to reference from. So for this guy, since they gave me the 23, I reference from there. So from this angle, I have the opposite side and the adjacent side, which means that I have to use the tangent function. So the tangent of 23 is equal to the opposite over the adjacent. The opposite was x, the adjacent was 53. So in order to solve for x, I multiply by 53 on both sides to get x alone. I just punched that into my calculator and I wrote down the decimal 22.4972. Okay, this was my reference angle for part B. So I have the opposite side and the hypotenuse, which means I'm going to pick the trig function sine or so. And I would set it up as sine of 57 is equal to the opposite side, which is 14, divided by the hypotenuse, which is b. In order to get b alone, you have to multiply by b on both sides of the equation. These would cancel. And then you would have to get, it would be b sine of 57 is equal to 14. And then in order to get b alone, you'd have to divide by sine of 57 on both sides. And so this is what you're plugging into your calculator, 14 divided by the sine of 57, which is 16.6931. Okay? And then I'm going to use one of your guys' answer sheets for the Eiffel Tower question. So it says, a tourist whose eyes are 6 feet from the ground is standing 500 feet away from the base of an Eiffel Tower in Paris. The Eiffel Tower is 984 feet tall. What is the angle of elevation of the tourist's eyes to the top of the Eiffel Tower? So what is this angle? So we know that this distance was 6 feet and this whole distance was 984 feet. So the first step that we had to do was subtract off this 6 to get 978. Okay? And then we filled in the rest of what we knew about the picture. We knew he was 500 feet away. So from this angle that I'm trying to find, I have an opposite side and an adjacent side, which means I need to do tangent, but we don't know what the degree is. That's what we're trying to find. So tangent of x, or tangent of theta, or y, or whatever variable you want to call it, is equal to 978 over 500. In order to undo a tangent function, you have to apply the inverse function. So x would be equal to the tangent inverse of that ratio, which is this decimal, 62.9217, which was the answer. That is all that I have for you guys. So study, study, study. I know this video was a little bit longer, but you can fast forward as much as you need to. So with that, good luck.